I welcome you to another wonderful session. In this particular lesson, we are going to continue with our lesson called Data Visualization with Excel charts, and we are going to explore some charts to understand their foundations, to understand when and how we use them, because this is very, very important to help you to know the basics of charts and when to create charts with Python. When it's time to use libraries like Matplotlib and Seaborn, you are going to have the understanding of charts like histograms, scatter charts, box and whisker charts. You are going to understand when to use pie charts and all the charts that you need to know. This lesson will cover these visualizations and will explore the important areas in Excel that a data analyst needs to be effective in the industry. And so it all begins with Excel. Don't take Excel lightly. For some of you, Excel will be the main tool you use at the workplace. So please learn it well and make sure you have deep-rooted understanding and a strong foundation in it. The future is created by what you do today. So what we are doing today is what is creating the future, not tomorrow. What we're doing today is what is creating our tomorrow. And so it is important to do the right thing today, to study, to be in class like this today. And I'm happy that all of us are here in class. We are sowing a good seed. It is a seed, and whatever seed you sow, you will reap. So I'm happy that we are sowing this seed today, and what we are showing now is going to create the future. All right, so Excel is the most popular spreadsheet tool in the world, and as you learn Excel, you will apply your knowledge in other spreadsheet tools like Google Sheets and other popular spreadsheet tools. This lesson is data visualization with Excel, part 5. So we have a number of lessons done already. And I'm going to start this lesson by testing your skills in and your knowledge in what we've done so far. If you miss any lesson, please, you'll get it soon. If not for time, I would have shared the specialization app with you right now for you to see. But then you are going to see it very soon and you have access to all the videos. If you want them, contact Benedine and Benedine will help you get access to them. So this is actually our 6th lesson in this particular course. After this course, you will receive a certificate called Data Analytics with Excel. After this, we will tackle other tools in Excel and learn them practically. And before we conclude our program, we are going to take another course called Business Analytics. If you can hear me, please type Business Analytics in the chat and let me see. Today I'm teaching from restaurant, so my audio may be noisy. I don't know if you can hear noise in the background or I'm clear. And my video is also not perfect because I'm not operating at my workstation. Yes, so someone says I'm clear. I'm happy to hear that. It's Mami, great to see you. Yes, so very soon you are going to be taking a course called Business Analytics, and Business Analytics is where you apply your data analytics principles to the business environment. And so as you are learning data analytics as a tech or technical person, this time you learn data analytics with a business mindset. Know how to apply it to the various components of business, the various functional areas of business like marketing and all the various functional areas of business. And after that, at the workplace, you'll be able to think more as an analyst to help businesses succeed. Yes, it's very, very important that we have this kind of mindset, and we are going to do everything possible to make sure you have the right foundation. Again, we are treating data visualization with Excel charts. And before we start, I'm going to ask a few questions. So I'm going to show some pictures and I'm looking for the first person who can type within 3 to 4 seconds the name of the chart you see. So who can tell me the real name of this chart? If you can see my screen clearly, tell me the name of this particular chart. And I'm taking the first person alone. Okay. All right. So some people got it right. Some people got it wrong. A lot of wrong. A lot of wrong. Okay. And now people have stopped typing. So this chart is called a column chart. Please type column chart in the chart. As a data analyst, you need to remember the right name. And I believe we have gone through this extensively to explain why this is a column chart. And so if you missed this lesson, please go back and learn it. This is called a column chart. It is a type of bar chart, but it is a vertical bar chart. And technically, the vertical bar chart is not called a bar chart. It is called a column chart. Now, as we learn about charts, one of the important things we are learning is to understand that not all types of charts are okay for all types of data. Every chart is best for some kind of analysis, some kind of data. And as an analyst, that is really the main knowledge and skill you possess. To know when to use a heat map, to know when to use a histogram, to know when to use a column chart, and know exactly when to use a bar chart or pie chart. Now, this particular column chart, from what we already learned, is ideal for comparing data across a few categories. Across category, you are comparing data across categories. So if you look at this picture, you can see that we are comparing departments in a company. These are called the categories. You may be comparing categories of products. Let's say laptops, desktops, smartphones, notebook computers, and so on. So we are comparing, and with this particular type of comparison, they have short labels. So you can see that we have marketing very short, sales very short, support very short, HR very short, and even the development department, we can even shorten it. And so it is best, and again, your job is to know when to use these charts. It is ideal for comparing categories, a few categories. I like that, a few categories. Because if you have too many categories, it becomes very difficult to properly tell a story with these charts or properly allow stakeholders to get insights from the chart. There are a few categories side by side, especially when emphasizing vertical growth or progress over time. So over here, you can see that these departments, they are being compared to scores. And you can see that the vertical growth is what we are emphasizing. And the first time you look at this, the first thing that comes to mind is which one is leading. And who can tell me which one is leading here? Yes, so you can see that sales is leading here. So this is very, very good. It is very, very easy to analyze this kind of data, this type of visualization. And your visualization is supposed to make the data analysis very, very easy for those who are viewing this for insights. All right. Sometimes you have thousands of rows of data, and it is impossible to go through the actual data sets and get meaning. But a data analyst is able to visualize the thousands of rows into a chart. And just by looking at this chart, you can tell what is happening. This is also another type of chart. And I'm looking for the first person again who can tell me what this chart is. What is the name of this chart? And I'm checking my chart to see the first person to tell me the name of this chart. And this particular chart, somebody says it is. All right. So I think I'll give it to the person who typed in full, because if you only type by, I think you've cheated a little. So I'm giving this to Marasi. So Marasi got the bar chart, and let's see, this is called a bar chart. You know, in our minds, the first one I showed is bar chart. in the minds of the everyday person, the non-technical person, the first one is what they refer to as bar charts. But technically, in professionals, in professional environments, the horizontal bars are rather called bar charts. With this type of chart, it is ideal for comparing data across many categories. You see, so if you have few categories, you can use the column charts. And if you have many categories, you can use this. Sometimes you see the chart of, let's say, the European Premier League, and there are over 19 teams, and they are showing their various their various points in the league table. And you can see that they use this bar chart, and they show all the 19 teams, and you are still able to tell, because with this particular visualization, you can use it to compare across many items or many categories, especially with longer labels. So if they are longer labels, you can see that even the labels can be written on the bars. All right, and we still have room to write. Even if there's no space at the left side, we can write the labels on the bars and it can be okay. And also, when emphasizing differences clearly without worrying about the time or the sequence. So this is a little bit different from the column chart. All right, so let me show you this chart. And with this one, I think everyone will get it. So let me see the first person to tell me what this chart is. And let me see who won this. And this one goes to anybody. I'm just taking the first person who gets it right. The first person who gets it right. All right. So Norbert got it. Norbert says this is a line chart. Congrats, Norbert. Norbert says this is a line chart. Let's give it up for Norbert. This is a line chart. Yes, wonderful. Now, this particular line chart, you can see that this is a very popular type of chart. It's very easy to read a line chart. As a matter of fact, I like line charts a lot. It's very, very easy to read line charts. I don't know if anybody can read what is happening here. You can see from the legend that we have software in blue, we have games in orange, and you can see the years at the bottom. And then you can see the trend of profits by year. Just by looking at this, you can tell that games made about 3,000 profits in 2016. You can tell which year games didn't make a lot of profit. Who can tell me the year that games really, really dropped? Okay. And apart from this, 2018, thank you, Anozi. Apart from this, you can also tell how software is also doing. And apart from telling how software is also doing, you can also get the correlation between the two products. And what I mean by correlation, I'm not talking about a relationship per se, but I'm talking about their various trends and how they are competing with each other. When it comes to correlation, we have different types of correlations, and we will see a few of them shortly. Now, it is ideal for showing trends or changes over time. So most of the time when you want to use a line chart, it is because you are showing changes of a particular item over time. So we are talking about software in 2011, software, the same software in 2012, in 2013, 2014, 2015, 2016. Now, all these are points, but they are points that have been joined by lines. So we call it line chart because after we plot the points, we join them. There are some types of charts that we don't join them, but with this particular chart, we are supposed to join them to form the line, and the line gives us the trend, and it allows us to see changes over time, especially when illustrating progression or fluctuation of data across sequential intervals like days, months, or years. And we call this time series data. All right. So most of the time, if you have data that shows time series, then the best type of chart to use is a line chart. As for this, if you don't know, I'm going to evict you from the program. So who can tell me what this chart is? And this chart everybody knows and everybody remembers. And Lucretia, I give this to Lucretia. This is called a pie chart. This is called a pie chart. I think we studied something about pie charts, and we understood that although this is a very common chart that everyone knows there is a perfect time to use a pie chart. There is a right time to use a pie chart. And pie chart is used for some specific types of data. And so, number one, we use pie charts when we want to compare parts of a whole. I like that already. Parts of a whole. You see, there are different types of analysis. And for some insights, you are looking for the performance of one particular item out of a total. So when you ever face a situation when you are comparing an item's performance with the total, then you know that this falls in pie charts. For example, 40, let's say 40 is laptops. So we are talking about products, and you can see that there are about 5 products here. And we want to see how laptops did in comparison with the whole. So we can say that laptop made 40% out of the whole. Out of the whole, please type whole in the chat for me. And so anytime you have such an analysis, you want to know the right type of charts to use. With this particular analysis, you are not going to choose a line chart. A line chart doesn't really tell you the performance of one item out of the whole. For example, there are 5 companies competing in a certain market, and these are the companies in that particular industry. Let's say communication industry in your country. Maybe you have MTN, maybe you have Airtel. I don't know if Airtel is in your country. If Airtel is in your country, you can let me know. Maybe Vodafone is in your country, maybe Glow is in your country, Etisalat, or I don't know the other networks. But let's say in your country, there are 5 competitors, and you are supposed to perform an analysis of how MTN performed out of the whole, or how MTN is performing in the communications industry. And in Ghana, let's say the data tells us that MTN has 40% of the market share. So this is a very, very specific type of analysis. And as an analyst, you have to know the type of chart to use for this analysis. And the best type of chart is pie chart. The second point says that shows percentage distribution. So if you are looking for the percentage, you know that you are looking at pie charts, because the word percentage already creates a whole. Because when percentage comes to mind, a number represents the whole when it comes to percentage. Who can tell me the number that represents the whole when it comes to percentage? I know this is 100. So anytime you are looking for the percentage, then it means the whole. Sometimes you are looking for the degrees, okay? You're looking for the degrees. What is the number that represents the whole of degrees? Who can tell me? All right, so when it comes to degrees, you can see that it is 360 representing the whole. And as a matter of fact, a pie chart is made of a circle, and circle is perfect for degrees. And if you look at the various shadings and the various divisions, they all have angles and they all have degrees already. So pie charts can be used for a type of analysis where you are looking for the degree. And so in that case, you are not going to use a percentage. You are going to use the degrees out of 360. Right now, we are looking for percentage. And so we are working with 100. All right, we are working with 100. All right, the third point says that use small data sets, and it works best with 5 to 7 data sets. Now, although pie charts are more suited for checking the parts of a whole, if there are 30 items, pie chart will be incredibly difficult to analyze. And so pie chart is best for data items that are between 5 and 7. 5 and 7. So if you are having 5 and 7, you can use pie chart for it. It's best for it. All right. Because if the slices are too small, it will be hard to tell. With this particular type, this chart you are seeing, the parts are just 5, and so it is very clear, very easy to tell. The last time we saw what is called pie of pie charts. I don't know who remembers pie of pie. I don't have the picture here right now, but if you remember, let me know in the chat if you remember what is called a pie of pie charts. And the pie of pie allows you to represent more data sets when the items are many. It's one way of solving it. And Esimame, thank you so much. You remember. Now, sometimes if the items are so many, but we have some top 5 or top 3 or top 4, what you can do is to only focus on the top 4 and then leave the last slide for others. All right. So let's say we have 20, 40, 50, sorry, 20. This got 40, so 60. This one 10, so 70. This one 10, so 80. So what you can do is to say that this is others. Because there are so many, we can't slice all of them into smaller pieces. So we give them one shading and we call them others. I remember in some of the elections in Ghana, we had a lot of, how do we call them? We have a lot of candidates, and during the visualization of parties, during the visualizations, when the results were coming out, all right, please, if my network goes up, Bernadine, let me know and I'll connect and we'll continue. All right, now, instead of reporting the results of all the parties or candidates, they decided to focus on the top 2 parties, and the rest, they call them others. So they had some charts. They showed in Ghana, we have NDC, we have MPP, and the rest, they called all of them others. So I remember one election like that. That's how they represented it. So if the data items are so many, you can use that approach to represent it. We also have the next point says highlight key differences. Effective when category sizes are noticeably different. Yes. So with this, you can see how they are very, very different and they are very, very clear. You can see the slice for the yellow, the slice for the various colors, and you can see that they are all noticeably different. Simple and quick comparison, useful when visual summary is more important than exact values. Yeah, so with this particular chart, by just looking at the visuals or even the colors, you get an idea of the data. This simple chart can come from hundreds of thousand rows of data, but then you can just see it in a second and understand what is happening in the market. All right. This is another type of chart. So if you know this chart, let me see in the chat. All right. So I can see a lot of answers in the chat. and most of you got it right. This is called a scatter chart, or a scatter plot, or an XY scatter chart. As a data analyst, you are going to be working with a lot of scatter charts. You are going to be seeing a lot of scatter charts, and you are supposed to understand scatter charts quite well. You are supposed to create a lot of visualizations in scatter charts and really be good with it. This type of charts uses dots to show the relationship, or what is called a correlation, between two numerical values. Sometimes we call it the XY scatter chart. And what it means is that there are two numerical values, and we are checking their relationships, how one value affects the other. How one value affects the other. For example, hours of studies and exam scores. And so you are going to be given the data set where we have hours of studies of each student and their exam scores. So A studied for 3 hours and scored 70%. Student B studied for 4 hours and scored 80%. Student C studied for 5 hours and scored 90%. And student D studied for 6 hours but scored only 30%. And so at the end of the day, look at the score and the hours of study and plot the charts. We have one item appearing on the x-axis and one appearing on the y-axis. This is why it's called the XY scatter plot. And so we will have one variable, which is hours of studies, which is called the independent variable, and then the score on the y-axis called the dependent variable. So based on each item or each person's course and the hours, you go through the chart and you plot. At the end of the day, you are supposed to analyze whether there is a relationship between the number of hours you study and the scores you get in the examination. As a data analyst, you cannot just tell that it is yes or no. You need to analyze the data through scatter charts or scatter plots to be able to tell whether there is a relationship. If there's a relationship, then a decision can be made based on that. In business analytics, if there's a relationship between, let's say, the weather and the sale of a particular product, then a decision can be made that out of these two variables, weather and sales, there is a relationship. And so if the data analyst is able to use analytics techniques and scatter charts to tell that there is a definite correlation, then the business can make a decision based upon that. But then, if after the analysis of the data, we say that there is no relationship, then it means the company doesn't have to worry about making certain investments. Will this kind of information be useful to a business? If yes, let me know in the chat. Will this kind of information be useful to a business? All right. So someone says, yes, of course, this will be useful to a business. And this kind of information, you can only acquire it from the analysis. You cannot just tell that studying for long will give you good results, because I know some people who study for 2 hours and they get 90 and above. And I know some people who study for 8 hours and they still get 30. Why? All right, so based on the data you have at hand, you can analyze and tell. But then what you are looking for is a correlation. You want to determine if there is a correlation or not, and what type of correlation there is. Now, if the dots in the charts form an upward trend, it indicates what we call a positive correlation. This type positive correlation in the charts. If by looking at the data, you can tell that the dots, the actual dots, they indicate an upward trend, then you can say that there is a positive correlation. I'll talk more about positive correlation, but this means that as the independent variable increases, the dependent variable tends to increase as well. So it shows a positive correlation, meaning that the independent variable, we talked about independent variable in our previous lesson. If you want to understand them well, you can watch that lesson to know which one is the independent and which one is dependent. When we are comparing these two variables, one of them is independent and one is dependent. All right? Because the dependent one is dependent on the independent one because it changes based on the independent one. All right? So the hours of study is the independent, and then your score depends on that. And we check the correlation at the end of the day. Now, if the dots are scattered randomly with no discernible pattern, it suggests a little to no correlation between the variables. And this is very, very good information. And an analyst can say that there is no correlation. And the scatter chart can tell. When you use a scatter plot, when you are analyzing the relationship between two numerical variables, we call this show correlation, or we call this correlation analysis, when you are analyzing correlation. Also, when you want to identify outliers in the data, outliers refers to values that don't follow the pattern. And so if you look at this particular data, you can tell that we have outliers. Do we have outliers in this data? Just by looking at this. And so sometimes you want to report whether the data has outliers or not. In data analysis, we have a term called outliers. And outliers refers to values that don't follow the pattern. And so if you check this particular data, you can tell that some of the values don't follow the normal pattern we have here. You can tell that some of the values don't follow the normal pattern. And if you look here, you can see one data item here. You can see one here, and these are called outliers. They don't follow the normal trend that the data is showing. They don't follow that. So this is referred to as outliers. Now, it said when you want to identify the trend or the pattern in the data to understand the distribution, you can also use your scatter chart to tell. Now look at this and tell me if this particular chart represents a positive correlation. Because this example, I brought it here for you to understand what is meant by positive correlation. As a data analyst, you report a positive correlation when you can see an upward trend. This is what that means. When we say an upward trend, this is what it means. You can see that there is a trend. That trend helps us to understand what is happening if there's a correlation, and this is called a positive correlation. And it says that when the independent variable increases, the dependent variable tends to increase as well. And so you can see that when x is 40, this y is 100. When x is 60, y is more than 100. When x is 80, y is more than the previous one. So you can see that the data shows that upward trend, and we refer to this as positive correlation. Now, we also have what is called no correlation, all right? So as an analyst, when you are given data to analyze, and after plotting the data items on a scatter chart, first, you know the type of data you are dealing with. You are dealing with two numerical variables, and you want to find correlation. So the idea comes immediately that you need a scatter chart. But after plotting the chart, if this is what you see, would you say there's a correlation? Would you conclude that there is a correlation? All right, so you say that no, there's no correlation. And so this is an example of what no correlation looks like, or what we can say that no correlation. So you can see that there is no relationship between the two variables, okay? Even though it looks like it. You see, businesses make decisions based upon data and based upon data analysis. Businesses don't make decisions based upon assumptions. Businesses don't make decisions based on what someone feels like, based on feelings. Sometimes not even based on what we think we are seeing. Because sometimes you may think that there is a correlation between the weather and the sales of a product, but after the analysis, you can tell that there is no correlation. You can tell. Sometimes you may think that one particular product will do well in one particular location, but after the analysis, you can tell that the location doesn't matter. Or the location matters. All right. So based on the data you have at hand and based on the analysis, you can tell whether there is no correlation. When we say there is no correlation, it means that changes in the independent variable shows no consistent pattern in the dependent variable. So there is no consistent pattern. So the distribution or the trend or the pattern of the data points, the dots, can even give the results of the analysis. In scatter plots, we have something called negative correlation. Please type negative correlation in the chat for me. We have something called negative correlation as well. Let me see that in the chat. Negative correlation. You can hear me loud and clear. We have something called negative correlation. Now, which one is negative correlation? This is an example of what a negative correlation looks like. This means there is an inverse relationship between the two variables. As the independent variable increases, the dependent variable rather tends to decrease. So you can see that when x is somewhat 70 something, y is just 100 and something. But when x was 0, y was 200. When x was 20, y was 170 something. So you can see that there is a negative relationship. When one is increasing, the other is rather decreasing. And so you can see how the curve is looking like. This is called negative correlation. But positive is when x, the increase in x, also shows an increase in y. This is very important to understand and very important to know in this particular field of study. We have to understand that not all charts work for all types of data, and as an analyst, you need to be a specialist in charts. The last time I told you that someone went to the hospital, did some scans, saw the results, but couldn't understand it. The person did X-ray, was given the image, but couldn't interpret it because the person is not a specialist. But when the doctor saw the same image, the doctor was able to interpret it. In this particular field of study, you need to be a specialist when it comes to charts. You need to know when to use what type of charts. You need to know how to interpret your charts. And you need to understand that different types of charts are suited for different kinds of data and different kinds of analysis. Based on the data we have, we may choose a particular type of chart. And based on the insights we are looking for, we may choose a particular type of charts. So all of that's determined. In this particular lesson, we want to take a look at what is called histogram or histogram charts. Please type histogram in the chat for me. If you can hear me loud and clear, histogram. I think this is one of the most interesting types of charts in data analysis. And it's very easy to work with it. Because most of the time, when it comes to histogram, we talk about one particular keyword, which is what I'm highlighting. So if you can see my screen, please type what I have highlighted and post it in the chat. And most of the time we talk about range. Thank you so much, Newman and Anozi and Marasi and David and Esimami. Thank you, Lucretia. We look at range. For example, we look at 60 to 70. And this time we are talking about the score. But we don't want just the score, we want the range between score 60 to 70. How many students scored 60 to 70? Is this an important analysis we want to find out? Let's say between 60 and 70, how many students scored 60 and 70? Is it an important analysis? Is it an important analysis? We want to know the range of students who score 60 to 70. How many students score 60 to 70? And most people are saying, yes, this is an important analysis. Now, from this histogram, how many students actually scored between 60 and 70? After analyzing this, how many students score 60 and 70? There are 4 students who scored 60 and 70, and that is so amazing. And tell me how many students scored 90 to 100. 90 to 100. Please tell me how many students scored 90 to 100. Wonderful. This is really, really good information. And this is an amazing type of chart to use. With this histogram, you can give a lot of information, a lot of insights to stakeholders when you use this type of charts. A histogram is a type of chart that shows the frequency distribution of continuous data. The word frequency means how many times or how many times, how many times did this happen? How many times did this range happen? So we talk about continuous data when we are looking for the range from A to B. And we can know the frequency. So between A and B, we got 3 times or 4 times. So we are looking for the frequency. Please type frequency in the chat for me. This is very, very important. Type frequency. Type frequency in the chat for me. Thank you. So a histogram tells us how many times, or what is technically called the frequency, something happened within certain ranges of values. All right, so this is when you use histogram. When you look at all the visualization lessons we've taken, you can see that each particular visualization has a particular use case. As a data analyst, you need to be familiar with these visualizations. And it's very good you are learning this now, because you will not learn it again when you get to Python. You are supposed to apply this knowledge in Python when you are working with Matplotlib and Seaborn. You have to apply this when you get to Power BI, when you get to Tableau. You are not going to take this lesson again. So it is important to understand when to use histogram, because it shows you the frequency. For example, if you are looking for the ages of students in a class, we have a lot of students and we have 100 students, and you can see that there are different types of ages. We are not really interested in the individual ages, but a histogram can show how many students are between 18 and 20 years old. How many students are between 21 and 23 years old, and so on. So you ask yourself, is this good insights? Is it important sometimes for us to know how many fall in a certain range? Is it important sometimes? And of course, you've already answered yes. And so this is very, very important insights that you may need. And a histogram is just a perfect visualization to use for this. Now, each bar in the histogram represents a range. Technically, it is called a bin. Please type the bin in the chat for me. Type bin in the chat. Type bin in the chat. Type bin. All right, so this refers to the range of values. And the height of the bar shows how many falls into that range. I think this is self-explanatory, and this makes a lot of sense. It makes a lot of sense. Now, we have some data set here, and this is showing us 16 students in a class. Previously, we talked about 100 students. Right now, we are talking about 16 students. And you can see their various age groups. With this particular data, you may be asked to find the range, and you are going to be given the range to use. So over here, we have converted the same data into this particular form. We want to know how many students are between 18 and 20. And you can see that we have 6 students. How many students are between 21 and 23? We have 7. 24 to 26, we have 3. If you put all of them together, you can see that the frequency totals the total number of students. And how many students are we talking about? If you remember what we started with, please put it in the chat. How many students are we talking about? And there are 16 students. Thank you, Lucretia. You are following. Thank you so much. Thank you so much. And so with this, you can use Excel to plot this. You can use Excel to plot this. So you can see that between 24 and 26, there are 3 students. Between 21 and 27, how many students do you see from this particular histogram? How many students do you see? All right, so this is a very simple example. Most of the time, the histogram doesn't have spaces, but it's just a simple example that I'm showing you. And I'm asking a question between 21 and 23, how many students are within that age group or range? All right, thank you so much. Thank you, Marasi. Thank you, David, Esimame V. Thank you, Thomas. Thank you, Anozi. Thank you, Evelyn. Thank you, Darlington Okoka. Thank you, Newman and Nkululeko. Thank you, Valencia. Thank you all for following this class. This is so easy. This is so interesting. And learning data analytics is so amazing. A time will come, you'll fall in love so much with data. You'll fall in love so much with this profession. You'll fall in love and you will be happy to showcase what you are doing in this particular field because it is going to, you are going to connect with it. And it's going to be an exciting thing for you very, very soon. All right, so this brings us to the end of the lesson, and I'm going to give you an assignment, and I'm going to see how you are going to work on it. Maybe we can spend some time to do it right now because I'm going to give you the data set and you can just work on it. All right. So analyzing product sales performance using Excel. It says that you are a data analyst working for a nationwide retail chain. Your manager has asked you to analyze recent product sales data from 100 different stores to understand how sales are distributed. The goal is to identify patterns in sales volume and help the marketing team better target underperforming regions. So the first task is to download this data set. So please go to Retail Africa on GitHub. And the data set is titled Retail Store Sales Data. There are 2 retail data sets over there. This particular one is retail store sales data. Please download it right now and let me know if you have it. Let me know if you have it. Please download it right now. If you get it, go to GitHub, Retail Africa, github.com/Retail Africa, and click on data, and then look for retail store sales data. Retail store sales data. Let me see if someone has gotten it. Anybody? Okay, so Isimami has said you are so fast. Thank you so much, Isimami. Thank you so much. All right, so I'm going to give you this task. You use Microsoft Excel to analyze this data set and create a histogram that visualizes how many store units are selling. All right, just go through the data set and work on it. This is homework. Let me just allow you to take the time and do it. When you are done, send your work to assignments@retailafrica.com, assignments@retailafrica.com, and we will rate it for you. Please do all your assignments, work on this, and let's see what you will come up with. I want to see those who will do well in this. And next week, I'm going to look at what you did, and we will display it in the class. Thank you so much. I'm sitting in a restaurant. If not for my virtual background, you see where I'm sitting. This is an interesting place, and I'm happy we've been able to cover something. So I want to find out if you've learned anything at all tonight in this particular class. Let me know in the chat if you've learned anything at all. Thank you, Newman. Thank you. Thank you, Valencia. Thank you, Marasi. Asante Sana. Thank you, David. And thank you, Lucretia. Thank you, Anozi. And I see all of you. Thank you so much. And I will see you next week on Monday in our mathematics for machine class. I wish you all the best, and I'll see you later. Bye-bye.